Alright, so this video is on congruence, and it's going to help you with the last assignment in your packet, which is due next class. So make sure you attempt some of those problems, and we can go over questions that you have on it. So I'm not going to be having you write down everything in this video. I'll be specific about what I do want you to write down, so just make sure you're paying attention to that. So first thing is that congruent describes two figures that have the same size and they are the same shape. So we can actually have more than just two figures, but we're describing that the figures are exactly the same. So we could, mash these up. Yep, those are exactly the same. I can move these around. Yes, those are exactly the same, so they're congruent. This is something you want to write down. Next thing, which you'll be writing this down too, is how we mark things that are congruent. We mark congruent angles by putting those little arcs in the angle, and that's how we mark that they're congruent. So we have marked, with one little arc here, that these two halves are congruent, and this is an angle bisector, so we know it cuts an angle in half. Other ways we can mark would be, if I have these two angles, I can put two arcs. I could also have two other angles, and I could put three marks. I could also put a little tick mark, a little line through them. As long as the angles that we're marking have the same mark on them, we're showing that they are congruent. Alright, next how we'll show that segments are congruent is to put these little dashes, these little tick marks. So again, they can have varying numbers of tick marks. So this is our midpoint of a segment, so that's, that means that we have two congruent halves, and we've shown that with one tick mark. We have another set of congruent segments here we put with two, and then another set here that we put with three. If necessary, we could go up to 4, 5. It just depends on, what's going on in the diagram. We just have to make sure we're changing the number of tick marks as needed. So if we have different pairs of congruent segments, we don't want to just put one mark on all of them unless they really are all the same. So we should be writing this down on how we mark congruent segments. Alright, so now tying this back to transformations, which is the unit we're finishing up. This doesn't need to be written down, but I want you to think about, does a translation change the size or the shape of whatever is being translated? So we got T-Rex here, and does he change when we translate him? Next one I want you to think about is reflection. Does a reflection change the size or shape? Or, do we have no change in that size or shape? And last one is a rotation. When we rotate this ostrich around, do we have a change in the size or shape? And really the answer is no. So what we've learned about isometric transformations and congruency is that our shapes stay the same, and our isometric transformations are reflection, translation, and rotation. The one transformation that we've talked about that is not isometric is a dilation. And that's really why we didn't do much dilating in this unit, is because we've grouped them together by which transformations are isometric or keep our image and pre-image congruent, and then which ones are not isometric, which is dilation. So we don't need to write this down, but I want you to think about if we repeat an isometric transformation, so if we translate, rotate, reflect, would the final image be congruent to the original? And yes, the answer is yes. That's what makes something an isometry. An isometry or an isometric transformation is when we have those congruent preimages and images. So that's important to know about that word. If we mix them up, which is what we've been doing lately, we've been doing multiple ones, do we still have a final image that's congruent to our preimage? And again, the answer is yes. If we mix up all these isometric transformations, as long as we don't throw in one that's non-isometric, like a dilation, we will still have a congruent preimage and image. So then we're going to get into congruent triangles and really any congruent shape. And this is our symbol for congruent right here. It's an equal sign with a squiggle above it, and so we're talking about congruent triangles. And this is something I do want you to write down, this whole page. All three corresponding angles are congruent and all three corresponding sides are congruent. And what we mean by corresponding is the ones that go together, sides or angles that go together. Let's write that down. Okay, so then we have something called a congruency statement, and this is our congruency statement. And the important thing to remember is that order matters. Order is everything in this. We're going to be able to tell everything that's congruent in the two triangles based off of this statement. So again, this is a slide that you do need to write everything down, and in the next slide we're going to get into how would we use this to say what is congruent. So we have the same statement. It says triangle ABC is congruent to triangle XYZ. So what we can conclude then is that angle A is congruent to angle X because A and X are in the same spot. They are first in the statement. What we also can conclude is that angle B is congruent to angle Y because they are both second in the statement, and that angle C is congruent to angle Z because they are both third in the statement. The other things that we can conclude, so those are all the congruent angles, we can also conclude what sides are congruent. And so my statement's going to go away, but still based on order. So AB is congruent to XY. These are segments. So we have AB, first and second, is congruent to XY, which is first and second. We also have BC is congruent to YZ. So BC, which is second and third, is congruent to YZ, which is second and third. And then finally, AC is congruent to XZ. AC, which was first and third, is congruent to XZ, which is first and third. So all we're doing, we don't even really need to look at a diagram. We're basing all of this off of the order of the statement. Make sure you have this part copied down. Okay, so next, I want you to try these on your own. So, if we're saying that triangle ABC is congruent to triangle DEF, I want you to fill in these. So, what angle is congruent to angle A, which is congruent to angle C, angle E, and then which sides are congruent. So, remember, we're looking at the statement. It might even help to label the order of the numbers, number the order of the letters, to kind of help us work these out, and we need everything to be in the same spot. So make sure you pause the video and you work out this problem. Okay, and last thing is another part that you're going to be doing on your own, and I want you to finish the congruent statement. So what we have here is a diagram of two congruent triangles. We have everything marked, so we know that Q is congruent to J, P is congruent to L and R is congruent to K, and that's based off of these markings in the angles. Notice that when necessary we need to have different markings because we do have 3 different types of angles. We also have the sides that are shown to be congruent. So if I've already given you a congruent statement, PRQ, I want you to finish how do we have to order the second one. Because it actually doesn't matter how you start the order of the first one, just as long as the second one matches it. So I could have instead said PQR or RPQ, but since I've established that it's PRQ, the second one has to match it. So this will be the last part. I want you to make sure you write down, you have the diagram drawn, and then you finish the congruent statement. And so these parts that I've had you write down are going to be involved in the quiz that we have next class. If you have any questions about anything I talked about, please jot those questions down, and I will see you next class.